Unreal Engine 5.5 introduces geometry scripting into PCG. You're now able to actually use PCG in conjunction with geometry scripting to dynamically create meshes, boolean them, bevel them, do whatever you'd like, and then even output them to static meshes. For example, this is a little golf ball shape that I've created, and then I've populated all around. And if I want to, I can even change the shape, and not only will it change the shape inside of the one piece, it will also change it for all the other copies of it all automatically. Because not only is it actually updating all of them, it is saving a static mesh that you can then output and save wherever you'd like. So without further ado, let me show you how to use dynamic meshes and geometry scripting in conjunction with PCG. So to get started with dynamic meshes and geometry scripting, go to Edit, Plugins, search for Procedural, and you want to make sure you have Procedural Content Generation Framework, PCG, turned on, as well as Procedural Content Generation Framework, Geometry Script Interop. That is needed so you can actually get all the geometry scripting nodes for use with the dynamic mesh setup. So once you have both of these checked on, you'll have a little pop-up that might say it's in beta. Are you sure? Just hit yes, and then restart your engine when you're done. But once you're ready, go ahead and right-click, go to PCG, and grab yourself a PCG graph. This is going to be our PCG golf balls, because we're basically creating golf balls. I don't need a blueprint with this. In fact, we're just going to use this. So I'm going to drag this out, place it at origin, and this is going to be our little zone where we're going to populate everything. So now let's go ahead and open it up. And now before we get started, up top in the graph settings, and then here on the right under instance parameters, we want to grab ourselves a few parameters. We're going to hit the plus button 3 times. The first one I'm going to change to a static mesh, and I'm going to make it a static mesh object reference. And the second one I'm also going to make into a static mesh object reference. The third one is going to be, instead of a float, a transform. And now I can rename these. So I'll go ahead and rename the first one. This is going to be our base mesh. The second one is going to be our Boolean mesh. And the last transform one is going to be our Boolean offset. So that way we can go ahead and offset the mesh if we'd like to. But we're also going to be beveling in the scenario. And so I'd like to add a few bevel controls as well for convenience. So I'll add 3 more parameters. Now these are all going to be floats. That's fine. So I'll just rename the first one to be the bevel distance. Second one is going to be our bevel subdivisions. And the third one is going to be our bevel round weight. Now I'll set the bevel distance and the bevel weight to be 1. And we're pretty much all set with all the variables we need here. So now we can go ahead and start utilizing them. So to get started, I'm going to right click and search for Get Base Mesh. And now we can immediately start using the new nodes that we have access to. Starting with Static Mesh to Dynamic Mesh Element. Now by default, it plugs it into overrides. What I want to do is plug it into Static Mesh. Now you can plug in the Static Mesh here in the detail panel without needing to actually plug anything in. But this way we can pipe it in directly and automatically. Now, if I press D and sample it, you will see that we don't have anything in the scene. But with your PCG graph selected, if you go under your PCG component, settings, graph instance, and then parameter overrides, you can see all of our values are here. Now I could override my base mesh with something like a sphere. And I'll use the default arcade editor sphere. And as soon as I do that, you can see we have the sphere pop up. Now keep in mind, this sphere isn't actually here. It's because we're sampling it. If I press D and stop sampling it, you can see it has gone away. So this is purely the debugging that is showing the dynamic mesh. So keep that in mind. But really what we want to do is, now we have the sphere, I want to Boolean out all the little circles and little holes in that sphere. So for that, I'm going to drag out of base mesh and search for mesh sampler. Now again, it'll plug it into overrides by default. So I'll plug it into static mesh instead. Then we'll close it up. And here in the detail panel, we can go ahead and change up the settings. Now right now, it's sampling 1 point per triangle. And if I press D to debug it, you could see it is creating just a lot of points. Now this might be fine for what you want, but for me, I feel like this is too many. So instead of 1 point per triangle, I'm going to change it to Poisson sampling. And then under Poisson sampling settings, under sampling options, instead of sampling radius being 10, I'm going to change it to something like 20. And you can immediately see we have far fewer points. That's still on the sphere. From all angles, it still looks like a sphere, but we now have a lot fewer points that we can actually use. So now that we have that, let's go ahead and modify these points. We'll grab ourselves our transform points, open it up, and now I can get the get Boolean offset, which is our transform that we created earlier, and we can break transform attribute. This gets us to the translation, rotation, and scale, which I can plug in into offset min and max, rotation min and max, and scale min and max. And then I can close up the transform points node. Now, one important thing not to forget is in the transform points node, you want to uncheck uniform scale. Otherwise, the X value will dictate all 3 axes, which if you want to only be able to scale uniformly, you can leave it on. But right now, this is just points. We want to convert it into a dynamic mesh because dynamic meshes can only operate with other dynamic meshes. So what we can do is right click and search for create empty dynamic mesh. This just gets you basically an empty object. But from here, we can go ahead and append meshes from points. So the points are the points that we created here, and the meshes we want to plug in from our static mesh, or you could do it in the detail panel here. Now the mode here is single static mesh, which is what we want. You can also go by static mesh from attribute or another dynamic mesh, but in our case, I want to go ahead and plug in a regular single static mesh. So I'm going to right click and search for get boolean mesh, and that is going to go into our static mesh, and I'm going to close this up. So now if I go ahead and sample this and press D, you can see, again, nothing has happened. That's because we have nothing plugged in into the boolean mesh here in the parameter overrides. So I'll check this on, and again, I'll swap it out with the sphere. And when I do, you can see, well, yeah, it's spawning the spheres, but they're absolutely massive because we're using the same shape for our base and our boolean. So in our boolean offset, I'm going to open it up and overwrite it and change the offset here to be something like 0.12 in X, Y, and Z. And you can see when I do that, we now have a lot of little spheres all attached to this sphere. So that is fantastic. So we don't need to sample that anymore. Instead, what we want to do is actually perform the Boolean operation. Now, thankfully, Boolean is actually one of the new nodes. Boolean operation is under dynamic mesh. We can go ahead and select it, plug in original sphere into A, and the little spheres that we just set up into B. Now in the detail panel, by default, it is set to intersection, but in our case, I want to subtract it because I want to cut it out. Now under Boolean operation options, you have a few things that you can fill holes, simplify output, simplify planar tolerance. You have a few things here. We'll go ahead and leave them all at default, and then I'll press D to sample it. And as soon as I do, you can see, well, we now have this shape and it's all cut out and it looks pretty good. And if this is all you needed, you're pretty much there. But what I would like to do is add a bevel to it, because right now, all of these edges right here are very sharp. And if you ever looked at an actual golf ball, for example, they're not perfectly sharp because it would hurt. It would hurt quite a bit because it's not meant to cut things. It's meant to be a little rounded. And if you look at anything, even like your table, all the edges of your table are going to be slightly rounded. They're going to be slightly beveled. So that's what we want to do as well. And unfortunately, bevel is not one of those nodes that actually exists inside of the default setup right now. You have to do it through a custom node, but it's relatively simple. And the other thing I want to do after I do this is I want to re-UV it. Now, you don't have to re-UV, but I want to show you how to do that as well, so you kind of get a bigger understanding of how the dynamic mesh setup works and how you can get it all working all together. Just keep in mind, the more things you kind of stack on top of each other, the more expensive it's going to be. It's not meant for real time, especially to re-UV. That does typically take a moment depending on how complex the shape is. So to set up our custom node, I'm going to grab execute blueprint here in the top left. I'm going to drag it out. In the blueprint element type in the detail panel, I'll select any one of these. It doesn't matter which one. And then I will browse to asset in the content browser, and then I can delete it. Most likely you'll end up in this BP elements deprecated folder. I want to go into the regular BP elements folder. And here I can grab something like distance to density and use that as our base. So I'm going to scroll up to our PCG folder, and I'm going to grab our distance to density. I'm going to drag it over and I'm going to copy here. So now in our PCG folder, we have a copy of distance to density that I will rename to Bevel and UV mesh. And then I'll open it up. Now, before I do anything, because it opens up to the class defaults here, on the right, I'm going to change the category from density to custom, and I'm going to change the description to just be empty. This instead is going to be exposed to the library in our custom category. Or if you want, you can put it in a category that already exists. That's entirely up to you. But this is good now. And now we can come to the left where our functions are, open them all up, and open our execute with context, which is our main execution graph. Now, if I zoom in, right after this for each loop and their PCG tag data, I actually don't need any of this to the right. I can go ahead and delete all of this. I can also then delete the point loop body function, and I can also delete this PCG volume actor right here. We do not need it. We're not accessing it. So we'll delete it and plug this all the way through. So now we have a good base to start with. The only thing left to do here is to go to edit, delete unused variables, and delete all of these variables that we no longer need. So now we can get started with actually accessing the information for our dynamic mesh. So from the PCG tag data here, I'll drag out from data and search for cast to PCG dynamic mesh data. And the loop body is going to go right into here. And assuming that it has a successful cast, we're going to continue from here. Drag out of here and search for dynamic mesh. Get dynamic mesh. This is the mesh that is being plugged into our node. And before I continue too far, I'm going to compile this and go back to our PCG golf balls. And here on the left, our bevel and UV mesh is still under density. And the reason for that is because our node here hasn't been saved. So hit save here and I go back. We now see it under custom. So keep in mind when you rename the category, make sure to actually save the node, not just compile it in order to have it move to the correct location. But now we have this bevel and UV mesh. I can drag it out and bring it in. Only thing is, these takes points in and points out. We need to take dynamic mesh in and dynamic mesh out. So under the class defaults on top, you want to open up your input and output and your input and output pins. And for the allowed types, instead of point, you want to swap it out for dynamic mesh for both of them on the input and output. Now, when I compile it, you can see it is actually the same purple node and we can plug it all the way through. So now let's go ahead and start creating the bevel. Now, typically when you bevel, you want to do it by a certain angle. You want to select the hard edges. Now, by default, there's no way to select actually hard edges in terms of like normal edge hardness. But what you can do is select it by angle. So if it's over a certain angle, it will treat it as a hard edge, in which case it will bevel those edges, which is perfectly enough for us. If you drag out of your dynamic mesh, you can search for select mesh sharp edges. And this gives you a minimum angle to select. So anything above this angle of a bend will be considered a hard edge. So I'll take this and I'll plug in our sharp edges. We'll leave it at 20 for now, but this gives us a selection of those hard edges and it passes the target mesh along. The nice thing about dynamic meshes is the inputs and the outputs always have a pass through of your target mesh with all the modifiers. So from here, from the target mesh, I'll drag out and search for bevel. And we have a few options: apply bevel edge selection, region selection, and polygroup bevel. In our case, we're doing edge selection because we've just selected the edges with the previous node. So I can take the selection and plug it into our selection. And then I can open up our bevel options by right-clicking and split struct pin. And now you might notice a few settings here, sort of like the ones we created earlier with our parameters, like the distance, subdivision, and the round weight. I'm going to right-click on all three of these and promote them to variables. And once I have them all promoted to variables, I'm going to just come into the variable section, hit the icon on the right to expose them all so we have access to them. So now if I compile this and go back to our PCG golf balls and I open it up, you will see we have the bevel distance, subdivisions, and round weight all here. So now I can go ahead and get bevel distance, get bevel subdivisions, and get bevel round weight, and I can plug them in into their respective inputs. Now from here, let's say this was all we want to do. How do we then output this so it actually works? To do that, just drag out of the execution pin and search for construct object from class. It's under the game category here. And the thing you want to construct is their PCG dynamic mesh data. This right here, PCG dynamic mesh data. When you have it selected, you will see it says construct PCG dynamic mesh data, so you know it's selected correctly because it's a little cut off in this field here. Now I'm going to promote this to a local variable because I want to get access to it later. So I'll call it mesh data. And then we need to initialize this data and basically say what is in this data because we want to put the target mesh in there. So from this mesh data, I'm going to drag out and search for initialize. And the mesh that is going to be plugged into it is the in mesh. Now, if you wanted to, you could already assign a material in here, drag out of in materials, search for make array, and this is where you're going to assign a material to it if you'd wish. From here, I'll search for basic, and I want to assign this basic asset to material. And that's all I kind of need over here. Now we can go to the completed node from the for each loop, and now we need to output the correct information. So I'll grab our mesh data, search for make PCG tagged data. This gets us the information we need, and we can take this data, drag it into the tag data array, and it'll automatically create a make array node. We don't need the original tag data. We just take this and plug it in like so. Now we can compile this and go back to our PCG graph, select our node, which is, by the way, still called distance to density. We actually should change this. So in a bevel and a UV mesh node, go to node title override and change this distance to density to bevel and UV mesh. Now in our actual PCG graph, the name has not updated. I can press F2 and rename it here, or I can drag in a new one, which will have the correct name, bevel and UV mesh. Now it throws an error because nothing is plugged in, so don't worry about this error when you drag it in after it's set up. So if I select it now and press D to debug it, you can see if I zoom in, we now have bevels. Now it's not perfect bevels. There are clearly issues here. There are some holes in places. It is not a perfect system. So before I do the mesh sharp edges and the bevel edge detection, all of this, I'm going to take all of this and just drag it to the right a little bit. From our dynamic mesh, I'm going to drag out. I'm going to search for repair mesh. To get repair mesh to generate geometry, I'm going to plug this in right before our select hard edges. And then I'm going to take our target mesh and plug that into our target mesh. And when you do that, you can see all of those little spikes that were happening are kind of gone. It is much cleaner. Now, there's still some errors here. It is still not perfect, but we're getting better. The little holes are still there. We want to fix that. So after we apply the mesh bevel selection, I'll go ahead and detach these and move these over to the right. I'll drag out our target mesh and search for fill all mesh holes. I'm not going to leave it on default. It is basically done automatically. And again, after this, plug it all the way through, compile it, and you can see it has filled some holes, but there's other issues. That's because it has a little bit of a holes in between sections that we don't actually see natively. So to fix that, before I do this fill all mesh holes, I'm going to drag out and search for weld mesh edges. And I'm going to plug this right in between the bevel and the fill mesh holes. And immediately you can see those extra interior parts that were a problem before are gone, and it has indeed filled the holes here. Now, it doesn't do a perfect job. As you can see, the edge loop, you would like it to have created a triangle in a different manner. It created it this way, vertically instead of horizontally. So it's not a perfect system. If I right-click on fill options for fill all mesh holes, you can try playing around with the type of setup you want. You can do planar projection, planar projection, polygon, triangulation, etc. But I typically keep it on automatic as I have not found too much of a difference in this particular scenario. So while yes, this is technically a little problem, from a distance you won't notice it, and depending on the use case of this is probably just fine for you. But we also have exposed the bevel options, as you recall. So in our detail panel here, I can override the bevel distances. For example, I can make the bevel distance 2, and you can see the distance here is considerably longer. Now in some of these areas, the holes are quite close, so going so high is causing issues, so I'll keep it at 1. But I'm going to change the subdivisions to be 1 as well. And you can see this has slightly rounded it by putting an extra edge in there. I can increase it to 2, and it is just rounding it a bit more even so. So now we're getting a much nicer and cleaner result. And the bevel round weight, if I set to 0, will return that flat edge, but still has the subdivisions if for some reason you need those. In my case, I'll leave it as 1. So this is all great, but the problem is it's still using the old UVs, which has a little bit of an issue. So after our fill all mesh holes, I'm going to move this part all the way to the right. Now, this is a very complicated shape, and when you're doing auto UVs, spheres and round things really are the most challenging. So it's not going to give you a perfect UV that you could do yourself, but it'll get you a nice one to actually get started. And depending on what you're doing, especially if you're doing more material-based stuff instead of texture-based stuff, it might get you enough of what you need where you can apply a procedural material on top of it and be just fine. So again, between the fill all mesh holes and the construct node, I'm going to drag out of target mesh and search for auto UV. Now you have X Atlas and patch options. I'm going to use with the patch builder this time. Depending on your mesh, you might have better luck with X Atlas versus patch. This entirely depends on your specific mesh. And both of these types are actually available under the modeling tools if you want to play around with re-UVing something else and see how they work without needing to go through this entire PCG pipeline. It is always there for you to test with. So here, I'm going to right click on options and split it. So I have access to all the details, and the only one I'm going to adjust is the options initial patch count. From my experience, the way it works is it cuts the entire mesh into little patches and then tries to re-stitch them together as best as it can when it thinks it should. And the more little patches it has, the more of a decent job it does. It of course increases the compute time the more patches it has, so keep that in mind. That every time it has to recompile this node, it will need to re-bevel and re-UV and redo all of this every single time. So if you don't need to UV it, don't do it, because this will actually substantially slow things down. In my case, I want to do it to show you guys that it is possible and how you do that in general. But now I have this auto-generate UVs, I can go ahead and just push it all the way through. And if we take a look at it, nothing is going to change because we're not previewing something that would tell us really how it's UV'd. So right here under this materials initialized make array, what I can do is search for checker and get ourselves a checker material instead. And one thing you might notice, it looks pretty good. At the same time, it's not, because, well, doesn't this look exactly how it would have been before with the large sphere and the small one? Well, yes. In fact, this auto-generate UVs isn't actually working. If I go ahead and just ignore it and recompile it and take a look at it again, it is exactly the same. Now, I wanted to show this because I ran into this issue when I was testing it. And for some reason, when you're doing actual geometry scripting, this works fine. But specifically in PCG, in this configuration, you need an extra node beforehand for it to work properly. And that's this repair mesh degenerate geometry. For some reason, in this particular case, it wants another repair mesh degenerate geometry before this auto-generate UVs. So I'll go ahead and plug this in right before target mesh into target mesh, pipe it all the way through, just like so. Again, I will leave it as default and I hit compile. It will take a little bit longer to compile now, but when I do, you could see it is now actually different. And you can see that it is actually using quite large pieces. It's hard to tell because it's cut up so much. So what I'm gonna do is find this checker material by navigating to it, then right-clicking it, create material instance, and then I'm going to drag that into our PCG folder. And once it's moved here, I can take this material instance and apply it to here instead. And the reason I'm going to do that is if I open it up now in the detail panel, I can go ahead and change the density. Instead of 20, we'll set it to be something like 200, which seems like it tiles it quite a lot, and it does. But now it is a little bit easier to see exactly where the seams are and how it's tiling. So again, it is not perfect, but the main thing is it is actually all scaled uniformly now. Now, there are nodes just to repack this without actually needing to re-UV. I'm not going to go into all nodes that Dynamic Mesh has in store with geometry scripting. There are lots of tutorials on stuff like this already on YouTube if you're interested in that stuff. I'm just showing you the basic overview of the system in conjunction with PCG. As always, this project file is going to be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord will be down below as always. Thank you again to the patrons. Let's get back to it. Well, let's say we're very happy with this. This seems exactly what we want. I can now go back to the golf balls and let's stop sampling this, and instead let's actually spawn it in the world. So I can drag out of this bevel and UV mesh and search for spawn dynamic mesh. It doesn't need any settings in the detail panel. It takes the information right from the input, and without sampling anything, we now have the sphere already in here. Now that's wonderful, but now let's go ahead and spawn it everywhere in the world. Now I don't want to spawn a dynamic mesh, but what I want to spawn is a manual mesh, a static mesh that I have saved from this dynamic mesh and then it's populated everywhere. So that way, instead of having hundreds of dynamic meshes that are constantly being recomputed, it is one that is then being saved and then populated everywhere else. The one note with this is keep in mind that the save functionality will happen every time it is recomputing the graph, which means while you're working with it, you might want to have the save unplugged so that way it is not saving on every time you modify any node. But to save it, all we need to do is drag out of spawn dynamic mesh and search for save dynamic mesh to asset. When I do this, it is going to recompute, and then immediately it's going to pop this up, save PCG asset, and I can specify, for example, inside the PCG folder, I want to save it called SM_golf ball. I just save it right there. That's great. It's going to save it. And as you can see, right here is our SM golf ball that we can open up, and here it is. Here's our mesh. It already has the material that we've applied to it. And if we open up the UV channel 0, here are the UVs that it has created. Again, are they good UVs? No. But this is also the worst case scenario you can possibly do because it is a sphere booleaned with other spheres. But now if you have the mesh all set up and you're happy with it and you don't need a dynamic, you can export it, re-UV it, and bring it back in and continue working with it as a static mesh. In our case, we'll just go ahead and take the static mesh now and spawn it all over the place again. So as I mentioned, I'm going to detach this so it doesn't constantly keep saving every time it recomputes. And then in the detail panel, I don't want to open the save dialog every single time. That's going to be a pain. I want to always save it in the same location and the same name. So I'm going to uncheck save, open save dialog. And then in the asset name, I'm going to call it golf ball. And then the asset path is where I want to save it. I want to save it in the same location under content, PCG. Now the path, instead of content, it's actually game. So that's something to keep in mind. Content is game in this path. So what I type in is /game/PCG/. So it's going to go into the game, which is the content, PCG. I'm going to press enter. And then next time we update this and plug this in, it will just continue to save it into the same directory and overwrite our little static mesh. So fantastic. So now let's go ahead and scatter this static mesh that it's saving all over the place. For that, I'm going to take our input, open it up, and grab ourselves a volume sampler. Now, as I'm doing this, every single time I'm changing something, it is recomputing this node, which is also quite a bit expensive. So I'm actually going to detach this as well. It's going to complain, which is fine, but now it is no longer computing this on every single node I'm changing, and I'll replug these in once I'm done. So for the volume sampler, I'm going to change the voxel size to something like 500 in all axes. And then I want to prune some. So I'm going to search for density noise and then a density filter. For the density filter, I'm going to change it to 0.75 to 1. So I'm only retaining 25% of all the points. At this point, I want to actually move the points. So I'm going to use the transform points node. I want to offset them between minus 1000 in X and Y to positive 1000 X and Y. I also want to rotate in all three axes freely, effectively, by putting it between 0 and 360 degrees in all directions. And I want to scale it between 1 and let's say 1.5 uniformly is fine. For here, I want to make sure I'm actually not overlapping the original dynamic mesh. So I'm going to use a difference node and plug the spawn dynamic mesh into the difference. And then I'm going to grab a self-pruning node so I can go ahead and remove any points that are overlapping. And at long last, at the end here, I'll use a static mesh spawner with the mesh entry being our static mesh that we've just created, our golf ball. So now this is all plugged in. Now I can go ahead and plug this in and plug the Boolean operation all the way through. It's going to recompute it and resave it. And if we look at our environment, you can see it is now spawning these golf balls. Now, I don't want this material here on all of these. This was a nice checkerboard for our base one, but I want all of these other ones to have this nice chrome that I created before. So what we can do is in the static mesh spawner, down here in the detail panel, I can use override materials. I can add an entry here, search for basic, and apply basic asset 2. Now, this will override the actual static mesh, but in fact, I want to overwrite the saved static mesh. So instead of this, I'm going to delete this. I'm going to unhook the saved dynamic mesh to asset while I work on it, as well as the bevel and UV mesh. And now in the saved dynamic mesh to asset, we can take a look at these settings. We have a copy mesh to asset options, and we can do quite a few things here, like recomputing tangents, the normals, removing degenerates here, quite some nice stuff. But the other thing we can do here is set up new materials and new material names. Now I want to replace the materials and add a material, and this is going to be our basic material, this nice basic asset 2 material. And I also want to apply nanite settings. So I'll go ahead and check that on. And then our nanite settings, make sure not to use the deprecated one. I'm going to just turn on nanite to be enabled. I'll leave everything else by default for now. So with that all good, I'm going to plug this all the way through, and I'm going to plug in this into our save dynamic mesh to asset. And if we look here, our first one has the material that we applied to it, but every static mesh that we're spawning now is using this basic material, which is what we wanted. This is how we've basically created this golf ball shape, UV'd it, assigned materials to it, and now saved it to our content browser. And now we can do whatever we like with it. We can export it, we can tweak it, we can use it again to Boolean something else. This really opens up the use case for PCG tremendously. Now, if you haven't seen all the other PCG stuff that's coming to 5.5, as well as a few other really awesome stuff, check out this video right here, where I go over some of my favorite things coming to 5.5 once it's fully released.